Can you hear me?
Yeah, I can hear you.
Cool.
Yeah.
Good morning. How are you doing?
Morning.
Good morning. Good morning.
Let's keep some Finally. So as you start, I will do a small intro. Then you show how to deploy memory. Then I will go through a set of slides which explain the fact that M Insight is super important. And from there you deploy M Insight and you show how you deploy microservice.
Sure, sounds good.
That is the plan of the day.
Okay. Well, we should leave it a few more minutes, wait for the stragglers to come in and people to show up. Good morning, Chuck.
Good morning.
And of course, this is recorded, so those folks that can't make it, they can catch up on the recording. And John's been pretty good about posting those promptly.
And it will be around 30 to 40 minutes, Reza.
Okay.
Yeah, Michael, while we wait, Michelle, while we wait, I looked at the document. I'm pretty excited about Mimic AI. It has a lot of power, what it can do. I mean, the possibilities are endless.
Very good. Thank you. Hello.
Hey, Michelle, welcome. Welcome back.
Yeah.
Roger has his own personal assistant.
Yeah.
Live personal assistant.
That's perfect. Well, we don't know. I mean, this just could be a very good avatar.
or he's doing an Elon Musk on us.
Yes. Like a little mini me. There you go.
No, this apple fell far from the tree.
People are trickling in. I got the word out last night and today. I think we need to get links out ahead of time, a little bit further ahead of time next time.
And it occurs to me that the link that's on Luma, maybe we should swap that out for the next event link, because that's where people go to. They're probably going to be clicking on that and saying, "Oh, what's going on?" I mean, if we thought about it, we should have given it one single link.
Yeah, yeah. We got a little dyslexic with links last night too. So
Yeah.
John, you're acting like it's cold in Tulsa with that beanie on.
it's cold, and I'm covering up hat head because I'm in bed head because I was up late editing video. So
Thanks so much. I saw those videos. That was good that you got them out promptly. Well done.
thank you.
Right.
Good morning. Ira got the beanie memo. I didn't. Maz got the beanie memo.
I wonder if I can do the master calendar as the link in Luma.
Yeah, maybe. I mean, it says there's Zoom. Anyway, we'll after this we'll have a little huddle and we'll sort something out. Okay.
I had to go find the link, and I'm kind of laughing with Victor and Dan because when the Afghan evac started, about a year later, we made a list of the biggest threats to Afghan families, and it wasn't the Taliban. It was Microsoft Excel and too many apps with information on them that have the same color. So
Yeah.
technology was our biggest obstacle some days.
No question there.
I was recently at Davos at the World Economic Forum, and I was a speaker at the MIT AI event. And it was like throwing a pork chop in a synagogue because everyone was praying at the feet of the God of technology for salvation. And I was like, you do realize that this is actually going to speed our extinction. And I explained why it would speed our extinction, because humans have turned 2/3 of the world's ecosystem into a desert through linear decision-making processes. And AI is a linear decision-making process, and it just literally speeds up that process. So because AI absolutely functionally cannot understand holes and patterns and how they function, it's literally going to speed up our extinction, but we can't even comprehend that. And boy, it was interesting watching all these super smart technology AI people just have a complete reset and have that oh my God moment. And I'm like, yeah, we're here. There's nothing we can really do about it. We're not going to stop it, but how do we reduce the harm it's going to do? When everyone is thinking that this is the solution to all our worldly problems, and it's not. So yeah, I have fun being in both the holistic world and the technology world, but looking at it as an outsider to see the errors before we hit them.
Roger, if I may, you said something about AI being linear. Do you think it will still be linear with quantum?
So it has no option to be but to be linear, because all computers function in zeros and ones. So by definition,
not with quantum though.
So by definition, it's a linear thing. So quantum cannot even it cannot even comprehend anything. How quantum functions. It's still linear decision making. A leads to B, B leads to C. It cannot go A to Z to green to pink to it can't function holistically and in patterns.
Roger, can we let's move on with the agenda. We're 8 minutes in. This is being recorded, so all the stragglers can pick it up later on. Let's all mute. I'm going to hand over to Michel Berger, CTO of Mimik. thank you so much. Michel, you gave us a fantastic sort of preview of what your workshop's going to be at the summit. And you did it in a crisp 30 minutes. So off you go, 30, 45 minutes. We're recording it. Thank you very much.
Okay, thank you. Good morning, everybody. So with me, I have Maz, who is our field engineer, and Pratik, who is an Edge microservice developer, and I think Claude is there, but that's our marketing guy. So what we're gonna do is it will be very practical because I have few slides, but the idea is to be super hands-on. So what we're gonna do is Maz will show you how to deploy MimoE, because we already had some question on the mimik channel about that. So he will show you how to deploy MimoE. Then I will go through some kind of architecture slide to show you some pattern and some of the things you can do once MimoE is installed. And after that, Maz will come back to show you how to deploy a utility microservice called MInsight, which is very useful to when you do development of Edge microservice. And also, we will go or we'll point you to some tutorial, because we have a whole collection of tutorial about how to create, deploy Edge microservice. And we even have a sample microservice to show you. So, all right. So let me pass the baton to Maz, and Maz, on you.
Sure. So thank you so much for that introduction. So without further ado, we'll jump right in. So let me share my screen. Okay. So I'm sharing my screen right now, and the very first thing we need to do to set up MimoE is go to our dedicated GitHub space. You can find that at this link here, which I will go to the chat right now and simply paste it in there so everybody has it. So here you can find the different runtimes for the different operating systems. I'm on a Mac here, so I will do everything related to Mac, but we also have Linux, Windows, as well as Android, iOS, and at the end of this call, after I deploy MInsight, I'll show you where to go for the tutorials of, actually I can do that right now. To see where the tutorials are, I've simply gone just mimik.com. I will also share this link as well too. And when we go to mimik.com, we see a button at the top. It's called Developers. We'll go into here, and this is where all of the documentation is. And if we want to go to the docs at the top, we can click on the docs, and this will take us to our docs page. And if we want to go to the tutorials on the left-hand side, we can see we have a lot of tutorials either on MimoE standard or the MimoE AI. So if you're interested about running our MILM or running our AI runtime, there's really good tutorial in here, specifically this one, implementing a single agent. This is a really good tutorial on how you can get started on running the MimoE AI runtime and deploying a model onto it and actually using it. I will actually share this link in the chat right now as well too. Besides that, if you're looking for how to develop with Android and iOS, we'll go back to the this one here, the MimoE standard. And on top of this, we can see we have a tutorial for Android and we have a tutorial for iOS. So with that being said, I will go to our GitHub space. And given that I have a Mac, if you have a Mac or a Linux machine, there's a very easy one-step way to install mimoe, and it is within this repository here. It's called mimoe setup. If we scroll down to the README and you have curl installed, you can simply run one command. It'll grab the latest mimoe from GitHub and then install that onto your system. But given that you are having an Apple OS or a Linux using either AMD 64 or an ARM 64 architecture. So for this one, all I will do, since we're not doing anything AI right now for this tutorial, I will just download the standard version, and I can download the standard version using this top command. So I will simply copy this command, and here I have my Visual Studio Code. This is my preferred IDE when developing, when working with and developing with mimoe, because it's very versatile, and you will see when I get to the deployment of the microservice that deploying a microservice is really easy within this workflow that I have. But we can talk about that a little bit, other options in terms of workflow when I get to the deployment part. So I've copied that command. If I just simply list out the different folders I have in this directory, I have a microservice folder. It is very, I recommend to you that you keep mimoe in a separate folder. So all I will do is I'll create a folder, mkdir mimoe. And then now I have another folder called mimoe in there. I'll simply go in there and I'll run that command. So once I run that command, it'll download mimoe. And as you can see from the logs here, I have mimoe now currently running on my machine. And that's pretty much it. I can see that it's the latest version 3.14.0. It's the developer version, and that it is currently running as a super node at this current IP. So that's pretty much it for running mimoe on Mac. And if you have other operating systems like Windows, you can simply follow the instructions here. It's a start.batch file, and it will start that for you. If you have a Linux device, similarly, you can run that command that I just ran, or you can follow these instructions to get the latest tar file. You untar it, and you can do it that way as well too. So, any questions on that?
And by the way, on Linux, we have different versions like AMD and ARM, but you also have a CUDA and a Vulkan version. So if you have a machine, like if you have a Nano or some kind of NVIDIA machine, get the CUDA version, because then it will use the GPU of the board in order to go faster. And then Vulkan, which is like an alternate version of a similar thing. So
and question, so it'll run on a Mac, obviously. Does it matter whether it's an Intel or the M series silicon? You're muted, Maz. You're muted. There we go.
Sorry, yeah, sorry. No, it doesn't matter. The script is smart enough to decide if it's an Intel or a silicon. Yeah.
Okay, good. I've got in my shopping list to get Mac Mini, and so I'm itching to try it out. Okay, thanks.
Yeah.
All right. So let me go to the more fluffy version of things. Okay, so let me share. We are back, and I share desktop too.
We had some questions. Dustin asks, "Is it okay? Would it work on a Raspberry Pi?" I think, yeah.
Yes, it will work on a Raspberry Pi, given that you flash it to run Linux on the Raspberry Pi.
Okay, and other ARM silicon
So yeah, so either ARM 64 or AMD 64.
Fantastic. Okay, thanks.
All right. So let me first quickly go through the way we approach the problem or the edge hybrid edge AI, and then we'll go through some architecture. So we decompose the problem in 4 stages, and stage 1 is local execution, where basically AI should stand on its own, meaning that you should not have to wait for going to the cloud. You should not outsource the intelligence, so the AI model should live where they're needed, on phones, gateway, desktop, cameras. That's the reason why we basically created a memory which run on all of this platform, is because we believe that for us, edge is not just a gateway, it's actually the end user device. And then it should be like, imagine facial recognition or sensor generating data. Maybe that way where the data should be analyzed, instead of having to go further away in the cloud or in the network in order to do this. So that's the first stage. The second stage is where you start, where it become interesting, because that's where AI understand the bigger picture. So it's about contextualization. So that where an AI should be able to query something, or in our case, it's memory, in order to know when, where, and how to act. So I can query memory, I get the context, and the context is of what are the microservices around me. So either on the same device or on the same context. And we have 3 levels of context. One is a subnetwork. So if you have device on the same subnetwork, like for example, a Wi-Fi network, the discovery will happen. Then you have proximity. So in this case, it's about geo proximity, but again, it's not because 2 devices are next to each other that they're on the same network. So it can be pretty far. And in this case, you need the cloud environment. So I'm assuming that in the case of a disaster recovery, if the whole infrastructure is down, only the subnetwork will be valid. But again, so we have a cluster by proximity. And the last cluster is by account, where all the devices on the same account will be discovering each other. And this is to create this notion of a virtual me, or like a broader, because now the device can be on the other side of the planet. So, but the contextualization allow you to say, okay, what are the microservices? And the context will be returned, will tell you all of these microservices are there, and with Mimic, basically you can reach them. So that's the what we guarantee is, as much as we can, you can reach them. Sometimes it's direct, sometimes it's through some form of tunnel, and that's the reason why when you look at when we start, there is a login which is a tunnel established. So it's either direct or through a tunnel. But again, it's really about making sure that as a microservice, you know what are the other things. So which means that we generally don't, from an architecture perspective, it's not the fact that I'm not anti-MQTT or a bus, but in our case, because we provide the context, you can do explicit addressing, meaning that you can reach the node or the microservice you want to reach, because you have the whole description of that microservice. So it's not like you don't publish in the blind. You go directly to the microservice you want to reach. So that's the next step after that is really about communication. So contextualization, as you can see, that doesn't necessarily mean you can communicate, because you may not have the authorization to do that. remember that there is an authorization aspect, and it's a kind of like the meeting room type analogy where you can see a person, but that doesn't mean that you can communicate with that person. So, and that's where the stage 3 is about AI to AI communication. So, which means that now models talk to each other, there is interaction, and all of this should be as local as possible. So, imagine like a fleet of autonomous drone robots or drones which can optimize route in real time by talking to each other based on the context in which they are. And then it's also about cross-domain. The idea is to say that a car, like a smart car in the home, is it a home solution or is it a car solution? And actually, it's neither one or the other. It's more one system which shrink and expand dynamically based on the context and based on which component you can communicate with. So a car in the home is one system because it's only one service mesh. A tablet of a firefighter surrounded by a bunch of smart sensors. It's one system because it's the microservice which will be running on the tablet will talk to the microservice which will be in the smart sensor. So all of this happened because of the context and because of the ability to do AI to AI communication. And finally, the last stage, it's really about choreography. Like at the edge, you don't want to orchestrate because if you orchestrate, that means that you have an orchestrator, and which means that you have a special node which has more power than all the other. However, again, at the edge, if that node disappears, what's happening? Which means that you will prefer a choreography pattern where every node and every microservice has enough to decide what to do based on the event it receives or it can emit and based on the context in which it is. So which means that now you, in the agent or multi-agent system, you talk more about coordinating versus orchestrating because events are being sent. Now, what are the agents doing? They're doing whatever they need to do based on what they can do. They may return other events and so forth. So again, back to the analogy of a meeting room, you may have an agenda, which could be an orchestrator, but you may not have an agenda. And at that time, it's more like a free flow type meeting. So these 4 stages are important because it's a gradation. So it's you always start with local execution, then you move to contextualization, then it's AI to AI communication, and finally the choreography. So what's happening? And the bottom line is it's really about low latency because again, all of this should not imply automatically that you do a round trip to the cloud. And also it's a different stage. For example, so we worked with some military and tactical is choreographed, strategy is orchestrated, but strategy is more the fact that now you have to go further in the cloud in order to have a more global view of the situation. So which means that and the two work together. It's, again, we're not anti-orchestration. It's more the fact that at the edge, you are choreographed, and when you go more to the cloud, that's where the orchestration happens. But again, it's really about low the latency and resilience, scalability, and whatsoever. So, what's happening when you don't use Mimic? See, when you develop an app UI on a phone or on a tablet, you have to do a lot of things. Like you have to include an AI runtime. You have to include a model management because you may want to update your model, which means that the AI runtime will invoke the model in order to get it and then execute it on the AI runtime. Then you have an AI chain. You use LangChain or LangGraph or whatever framework in order to basically invoke the AI runtime. You may want to invoke also a global LLMs because in order to refine the response or to refine the prompt, depending on how you want to do. Then when a device arrives in the same context, that's where the problems start, because you would like to do this, but you cannot, which means that you need to have some form of discovery, which is generally more like a cloud discovery, which means that this microservice or this agent will register to the cloud discovery, and on your app, you now need like a cloud-based discovery library in order to finally discover, and also you need some security, by the way, in order to secure the relationship. But basically, then you can talk to the other agent in order to do something more sophisticated, like accessing a smart sensor which has already an AI associated with it, or a camera or whatsoever. And that's what the point is. Like now, if you imagine that you have an ML-based recognition app which use a camera feed in order to recognize something, problem is the same. So you have to have a model management there. You cannot do this again, so which means that you have to have this cloud discovery. And now you also need an API gateway, because you need to be able to expose the API of your ML-based recognition in order to be invocable by your app UI. You need some form of security again. And now, because all of this, you can talk to this new app. And of course, because of the fact that all of this is actually a fairly complex situation, you may want to have some kind of observability framework in order to observe all the events which have gone through this solution in order to develop it. So that's what's happening with ArtMimic, and you realize that there are a lot of components to add in an app UI, which means that your app UI become like a monolith, not a backend monolith, but now a front-end monolith, because you have to have a whole series of library and so forth, which means that at least 60% of your app is not about the app itself. It's more about handling the fact that there are other components out there and you have to deal with them, which is kind of like all the operational aspect and the fact that operationalizing agentic solution is a key part of what will make agentic solution real. So, and then, by the way, if you have another app on the same device, none of this the previous service or the previous framework will be available, which means that you will have to replicate everything again in another app in order to achieve the same result. So at Mimic, in order to make things real, so agentic AI, we basically developed a whole series of components. So one of them is Mimoi, as Amaz showed you. It's actually fairly easy to deploy. And what is Mimoi? So Mimoi has a whole series of components packaged in the same piece of software. So it's an operating environment. It's fairly lightweight. It runs on many OS and hardware, but it's not just an OS. It's really the foundation of decentralized intelligence. So you have a microservice execution environment, which means that you can develop, deploy, and run microservice on top of Mimoi. You have an AI runtime, and it's based on the CPP Llama library in order to execute model. You have a node discovery. So one of a big secret sauce of Mimic is when Mimoi is installed, you have a mechanism of discovery, and it's not based on everybody broadcast to everybody else, because that will be flooding the network with a lot of events. It's smarter than that, and it's part of our secret sauce. So I will not explain deeper how it works, but it works. So basically, when you have Mimoi, you start to discover and then you can invoke memory in order to say what is around. Which means that you can create ad hoc service mesh. What does it mean? It's like a service mesh is a terminology on the back end when you have a whole series of microservices. The collection of microservices which form a system, it's like one service mesh, but it's the same here. However, in the cloud, the service mesh are generally configured. That's you don't discover a data center. You have it and you configure it. Where at the edge, everything has to be more ad hoc and by discovery. It's like a node appear and disappear, and which means that you have to be constantly aware of the change. Then we provide a whole series of management aspect like observability, zero touch configuration, and also zero trust security. So zero trust security at the end it's crucial because every node could be a threat. So which means that you have to you cannot assume that a node is friendly. So you have to verify token, certificate, and things like that in order to run. That's memory. So which means that in a fairly small package, we were able to bundle a whole series of components. And actually, I didn't mention, but there is also an API gateway, by the way, in order to expose API. So when you deploy your microservice, you will use the API gateway of memory to expose the API of that microservice. So all of this is packaged in one SDK or one piece of software, which is very easy to install, as Maz showed. Then we have a whole series of microservices which help development, like a model store, which allow you to store a model and then have an API to expose, to provide the ability to fetch this model. MILM is the API to execute a model, and it can act either by invoking the AI runtime or by acting as a proxy, and I will show you in the next slide the architecture of that. We have a mini RAG or mini vector database, which in order to implement RAG. MAI chain, it's a coordinator in order to do specific scenario. Generally, the scenario is you have one prompt, you interrogate many components, then you receive many results, and then you summarize the result using another LLM to get only one result. And we have many scenarios where you could have many sensors giving you an answer, and now you just want one answer. So which means that you summarize the input of all of these sensors using an LLM. So that's kind of like MAI chain handles this type of scenario, but that's a coordinator which then will invoke microservice. And then you have MInsight. So MInsight is allowing you to visualize the context in which the microservice is. So if you deploy MInsight on top of memory, then you have kind of a fairly simple web UI which tells you what are the nodes in the context, and that's very convenient when you want to debug and the solution. So all of these microservices are accessible. Like we have a GitHub link which have all of them, and actually Maz will show you how to deploy MInsight after my presentation. So how does it work? How does it look now with Mimic? So you have memory, you have an MILM which will invoke the AI runtime embedded in memory. You will have MILM fetching a model from a model store, and the model is generally has to be in order to run on top of our runtime, it has to be GDUF compliant, but otherwise the size will depend more on the capacity of the device itself. So now you have an agent running, which means that if you have another device which it has name, for example, like NIM stands for NVIDIA Inference Microservice. NIM already has an API gateway, but they didn't make the API discoverable. So you can use MLM as a proxy in order to make, or running on top of memory, in order to make this generative AI discoverable. So in this case, when now you have an MAI chain, the MAI chain will see the MLM running on its own device, and also the MLM running on the other device. Of course, if you have a knowledge base, MAI chain will see it. You can always invoke in MLM by configuration, you can invoke cloud LLMs in order to refine either the question or the response. And again, if you have another device running like a camera, running an ML-based recognition app, you can always put memory on top, or side by side, sorry, either to fetch a model or to make a microservice which store the result. And because now it's a microservice, this microservice will also be discoverable using the MAI chain running on the original device. Which means that when the camera generates results, MAI chain can see it, and now you can have an app UI, which will invoke MAI chain, and all of this magic thing memory provide will happen, which means that you don't have to implement in the app UI the whole set of libraries, because you delegate that to a local microservice in order to do it. And as you can see, the 4 stages are well described here: local execution, contextualization, AI to AI communication, because one AI will communicate with another in order to give results or to refine the result. And then all of this is really an adapted choreography, because every agent are still independent, but they are kind of like coordinated by this MAI chain, which trigger events, receive response, and then an invoke other agent at the same time. And of course, MInsight will be available in order to visualize what happened, which is actually quite important. And again, if you have another app UI on the same device, now the beauty of using memory is these microservices are available even locally. So which means that the other AI could either invoke the same MAI chain, which is already there, or could invoke the knowledge base, could invoke the MLM agent directly, or even fetch a new model, depending on what you do, or create another MAI chain which will define another scenario. So that's kind of like how you architect systems. So for example, if you now contextualize even more with disaster recovery, so you could imagine that this device is a tablet, which is what the firefighter has. You have cameras around, which will be on. You have a sensor, which means a smart sensor, and now you can coordinate all of these devices using the tablet of the firefighter in order to have local results. So, for example, that's kind of like one thing which could happen. Yeah, and then I will skip this slide. You will have the video, but it's more explaining that when you develop an agentic system, you have to think about the non-functional API. And I don't know if people will be familiar with a concept or a framework called FCAPS, but that's kind of like what FCAPS is now. Important, so which means that create an account, download memory and install it. You have tons of documentation. Dev.mimik.com, developer.mimik.com, and don't go through this. Start, and then you have a whole bunch of tutorials, by the way. We have a tutorial like we use Instruct, so you can go through the tutorial directly. You're using Swagger Hub to have the API. So if you go to Swagger Hub, you will see the API of MInsight, MKB, and others. And then finally, we have a whole bunch of GitHub links in order to, the last one being MimoE, what Maz showed you. Edge microservice is where you have the tar file of some of the microservice I described. And Mimic Git has actually an example microservice to develop. So that's kind of like what I wanted to show you. And now, so first, if you have any question, I will let's
Fantastic.
for that.
Okay. Michel, that was wonderful. Thanks so much. Very crisp. If you had the concept of a Hello World application, you know, most platforms, they start off with a Hello World. What is the Hello World application for MimoE or for the Mimic platform?
So the Hello World application for MimoE is actually a microservice which says Hello World.
That says Hello World. Okay, so who does it say Hello World to?
It's basically you deploy the microservice, you have an API, and then you use like Postman or whatever to invoke that API to say, and the API will return Hello World.
Return Hello World. Okay, so now let's imagine something a bit more complex where you now have a network of a few peers. Describe an application. Let's say, for instance, I've got a group of neighbors here, and they're all going to give us. We're all going to have access to each other's door cameras, so that just within a trusted group, we can go and browse through that. What does that look like on MimoE?
So, okay, interesting. So basically, what you will have, an application could be, again, a firefighter or someone with a tablet, which basically arrive in this trusted context and now can interrogate all of this microservice to say, what do you see, or what, yeah, what do you see? And then based on what do you see, there may be an MILM on the tablet to either summarize all of what do you see as one response. So which means that when the firefighter asks a question, what do you see? The response will be, oh, I see on this camera, I saw that. On this camera, I saw this, and so forth. So you could have a long description of what all of these local cameras have seen, or you can summarize, or you can be more precise, like, did you see, I don't know, a fire? And all the camera will say no, or one of the camera will say yes. So this is a type of
building a heat map of what the cameras see, but a digest of it. Like, okay, we're seeing smoke in the sky, and so now you'd obviously need to know the position, the GPS location of every one of those cameras as well. But that way you can surface up crowdsourced data, real-time data for emergency response. Okay, great. It'd be great if someone were to build that thing. That would be a
so,
great
but anyway, yeah, Maz will show you now how to deploy MInsight, and then and also how to deploy a more generic microservice. But any other question again? Otherwise, we'll go to the next level. All right.
This is great.
No hands up. Let's go.
Let's go. So Maz, okay, I'll stop sharing. Maz, back to you.
Sure, no problem. Let me bring my screen up. Okay, so the tutorial I'm about to go through is, so we're back onto our developer website here. If I just go, if I just collapse everything into the standard view, on the left-hand pane, again, we can go into tutorials. And if we go under MimoE Quick Start and we click on MimoE Serverless, we see a bunch of tutorials here. So what I'm going to quickly run you through is deploying Insight, which is right here. There's also an online follow at your own pace instruct. So if you don't have, let's say, a hardware to deploy MimOE on yet, you can actually follow an instruct kind of click through, go at your own pace kind of tutorial that you can deploy this exact same microservice in a cloud environment. So I'm going to quickly go through this tutorial here. Let me just share the link of what I'm going through. And then we'll get started. So we'll go back to my environment here where we last left off. We ran MimOE, and we can see that it's running still. All I'm going to do now is I'm going to open up another terminal window here, and I'm going to open up my menu here. So what I've done here is set up my microservice, which is the tar file that is the physical representation of the microservice that I want to deploy on MimOE. And now coming back to why I have chosen Visual Studio Code to do all of my workflow is because once after you deploy MimOE, it all becomes interrogating APIs or invoking different APIs. And for myself personally, I know there's other tools like Postman, and I'm not sure, or you can also use command lines such as curl to call APIs. But for me, I'm a more visual person. I want to know exactly what I'm calling and exactly what that API looks like. So Visual Studio Code allows me to pretty much type out an API, create like a post or a get, and provide those the body or the JSON body for that API, and actually I can call that API right from here. But this does require an extension if you are going to go with this route, and that extension that I'm using is called REST client. This extension right here allows me to type out APIs inside of my Visual Studio Code IDE, and actually allows me to call the APIs directly from the script. So if you are going to go this route, this will be the setup that you need to do. But if you want to go another route, such as curl or using Postman, you can also do that as well too. So going back to my API file here, the first thing that I need to do is create a project. So how do we do that? We go back to our Mimik website here, and then if we clicked on developers, we get taken to this page, and at the top we have a login button. So I'm just going to click on login, and I suggest everyone, if you're going to work with MimOE, you need to have a Mimik developer account. Since I already have an account, I can just put my email and password. But if you do not have an account, you can go into the create account and follow the flow here, and you can create your account there. So going back, I will simply log in. So after I log in, I am taken to my developer dashboard on the Mimik developer website, and there are two different variants of projects that I can create. For now, we will simply just stick to Edge projects. So I'll go and click on here to go into my different Edge projects that I have here. And since I already have one for local testing and local development, I can simply click on this one. These are the two pieces of information that I will need in order to be authorized to work with the MimOE that I deployed on my local computer. If you have a new account, this page will be completely empty for you. So you will need to click on this button here to create a new project, and you can simply just name it as a test. You can just name it as a test project, like for example, Kawaii test, and I'll create it. And then that project will be shown at the bottom here. So now it's pretty much the exact same thing, and I can get the exact same pieces of information. So now that I have this set up, we have to go back to our script and we have to set some environment variables. So those environment variables will be placed in an environment file here that I've already created. And these are for if you're starting out and with Insight, these are the three things that you will need. You will need a host address, you will need a developer ID token, you will need a client ID, an API key. So the host is simple in this situation. It's the local machine that I'm on right now. So that will just be HTTP localhost and the port that mimoe runs on, which is by default 8083. Oh, 8083. So now I need my developer ID token. My developer ID token can be found here. So when we went into our project and I clicked on get ID token, I get a developer ID token here. I can quickly copy that by clicking this button and going into here and pasting that there. Now I need a client ID, and then that client ID can be found at the top here. Again, I will click the copy button, go back, and paste it there. And now API key, this can be anything of your choosing. So I'll just leave it as 1, 2, 3, 4, and then I'll save the environment file. Now going back to my APIs, I can now interrogate the mimoe or invoke the different APIs on mimoe. So this first API is simply calling mimoe to give information about itself. So if I call this, I see that mimoe replies with some information about itself. Right now, since this value is empty, is because I haven't associated it yet with that account that we just created in the Mimik developer portal. I can see that I have an IP, I can see the name of my Mac machine and the node ID and the different version and the version that I have. So moving along, I need to get a token from the global services to associate my account on with the mimoe running on my local machine. And I can simply do that by running this next API. So I've got that token now. And then now I'm calling the mimoe dev console global API, providing this API key to give me an access token. So I'll do that now. So I'm given an access token here. And then now I can do a post on the same API to associate my account. And I'll do that there. So now it's saying that my account is associated. So if we go back to that original get me call, we can see that my account has been filled in with the account that I just associated with. So now this pretty much means that I'm authorized to deploy microservices and call that specific microservices APIs. So moving along, now that I have my account associated with the mimoe, I can deploy that microservice. So in order to deploy microservices, we're going to be interrogating mimoe's MCM APIs, which is Mimic Container Manager APIs. So this first call here is an images call. I'm simply deploying that tar file, which is the physical representation of my microservice onto the mimoe runtime. So I'm just going to simply make that call. And we see that that tar file has been deployed successfully onto the mimoe. Now the second step of working with the microservice, we need to start the microservice. So now we're calling the containers endpoint on MCM and providing it with some information. So this is pretty much the configuration of the microservice that I want, and I'm providing it with that API key so that I know it's secure. So I'll simply call this API now, and we see that that was also deployed properly. And the most important thing that we need to take away from the information provided here is the MCM base API path. So this is the base path that I will need to know in order to call the mInsight APIs. So this is how all of the APIs for mInsight will start. After V1 will be the individual APIs that will need to call for that specific microservice, but they will all start with this, and we will see that in a sec. This second API, as we can see, is calling. So if we go to host, localhost, and the client ID, we see that it's actually typing. I've already done it, but it's already setting this. It's following this pattern that we see in the MCM-based API path. It's the client ID, the microservice name, V1, and then I'm simply providing it with the token the access token that we got, so that when we go into the graphical user interface, we won't need to provide the access token again. So I'm simply just going to call this and get a success. And now I just want to quickly go over two other APIs, which is the get for the MCM, because originally we did a post images and a post container. Now we're doing a get images and a get container. So all these do is get the information of the different images or the different containers running on my MimOE runtime. So I'll simply call this, and we see that original when we initially posted the MimOE image, we see that same information coming from this get call. And if I call this get containers, we can see the containers running on top of my MimOE where we got that base MCM base API path. So what I will do now, since I know that all of my APIs for mInsight will start like this, I will copy this API path and I'll go to my browser, and I will simply just put local host and the port where MimOE is running. And I will post that endpoint, and I'll call the GUI endpoint and press enter. So now this is the graphical user interface for mInsight. And all I need to do now is post that owner code that I set up, which was 1, 2, 3, 4. And now I can use mInsight for my system here. So if I press send, I get information about all of the nodes, for example, get nodes on my network here. And I can see that I have, if I collapse this, I see currently on my network, I only have one node, which is my local node that I have right now. So I can also make other calls to proximity. If I press this, I can see all of the nodes that are in my vicinity. So if I collapse these, there should be a lot more. So yeah, so here I can get an idea about all of the nodes that are in my proximity. So there will be a lot because I do live close to the office, so I would be able to see all of the nodes that are actually around me within Vancouver and in the office. So I'm just going to leave it there. If you want to learn more about mInsight, again, you can follow the tutorial here. If you want to know more about the Hello World microservice that Michelle was talking about earlier, again, in the same area where this tutorial is, right underneath it, we have one saying creating a edge microservice using WebAssembly. Again, this is another tutorial that I suggest if you want to learn more about microservices and how to build them, deploy them on MimOE. This is a great tutorial to start learning about that. And again, it's on Instruct, so you can click through and learn at your own pace on how you can get started with that Hello World microservice. And that's it.
Maz, thanks so much. That's fantastic. Okay, look, we're at time, or just over time. John, what are your thoughts about the rest of the agenda for this call?
I mean, if this developer requests, I could stay on, you know what I mean, to dive deeper. And then they can also reach people on the Mimik channel, Mimik Hackathon channel. I mean, this has been very, very detail rich, and really excited for platform, which we can build some transformative tech on top of.
Right. So lots of detail in here. The recording will be available shortly for you to go over it a lot more slowly. Hopefully you've picked up on some of the links that were mentioned here. If there are any questions, I think we've got 1 or 2 more minutes. Hands up, and you can ask the question. I see some while shy people are waiting for their hands up, there are some questions in the chat. Let's take them, gosh, in reverse order. No, yeah, let's take them in reverse order. How about that? So
Hamid?
yeah, Hamid's question. Sorry for the late question. I was reading the document before the meeting a couple of weeks ago. How you challenge ephemeral connectivity metrics. I think this is just a comment. What's the best practice you recommend for developers deploying microservices at the edge through your platform? Okay, so this is more of a statement than a question. Okay.
I think with the level of detail and the
Yeah.
questions that are coming, it might be better to move them to the Mimic Hackathon Slack.
Cool. Okay. Very good. Yeah. So all of you, it'd be great if you were to ask that question in the Slack, because this chat goes away when this call goes away.
Yeah.
And the best place to get your questions answered is in Slack. Great. Well, thanks so much. Thanks, Maz, and thanks, Michelle.
Thanks, Maz. Thanks, Michelle. Really great, nutrient-rich discussion.
Brad,
No
do
problem.
you have some comments? I see you came off mute.
Yeah, I'm connecting to all my guys on 2 other platforms, but Mass A+, I've worked with a lot of developers over the years. JT's asking me about, GraphQL versus REST. I'm like, dude, let's just talk to Maz on the Slack. So, but yeah, that was very clear. That's it. What we've learned is this opens up so many things we didn't think were possible. And just as a quick note, talking to Ira in the last meeting, the biggest nightmare of parents is an earthquake hits, you're all in different places in LA. And to be interoperable, extensible, and secure in connecting those dots, this is really amazing stuff. A++.
Thank you.
And fantastic. And the thing I loved, what Michelle said earlier on, there's no conductor, there's no orchestrator. So the notion of orchestration, there's no conductor, so there's no single point of failure. I think
choreography is a great term. I've never heard that term used like this. Choreography of data points. That's a really cool concept.
And so as a high level concept, I think that was important. That's the guiding principle in Mimic. So
Yeah, that's what one of the discovery aspect is also like that. And again, it took us about 9 years to develop this discovery, because that's doing it without a single point of failure is a complex component.
Okay. Spectacular. Okay, well, thanks so much. We'll see you on the next call. Before we go, John, what is the next call?
Next call, 2/22 at 2 p.m. The first responder call with Brad, Victor, and Dan, and Christopher Collins, and just and maybe even Nelson Cox. It'll be a roundtable of those who are equipped to equip us technologists with the insights of what it's like to be on the ground in a disaster response scenario. Fantastic. So really happy Brad was here to get the tech deep dive from Michelle and team. And now we're going to go hear from the non-tech folks about their emergency expertise. So really exciting stuff.
Let's get that link blasted out to the folks on Luma. Okay.
Everybody on Luma is now invited to every calendar invite that we have moving forward.
That's
Fantastic.
5 o'clock East Coast?
Yes, sir. 5 o'clock East Coast.
Okay.
Okay. Keep well. Thanks.
All right.
Thank you, everybody.
Thank you so much, everyone.
Everyone.
Take care.
Bye.
Bye.
Bye.